everybody, it's me, Angela again. I was just watching this hilarious video on the internet. This little kid threw a huge ball, and then his dog jumped up and hit the ball back at him, and then the ball hit the kid, and the kid got knocked over. I love that stuff, it's so funny. Then I got to thinking that this little video shows the perfect example of Isaac Newton's 3 laws of motion. Want to talk about those laws? Yeah, you do. So in the 1600s, there was this famous scientist and mathematician named Isaac Newton. He looks more like a keyboard player in some 70s band if you ask me. Anyways, he was able to come up with 3 laws that describe how pretty much all objects move. And we still use those laws today, 400 years later. His first law was all about how and why objects start moving or stop moving. The second law is all about how the acceleration of some object depends on how much mass it has and how much force you put on it. Newton's third law is all about how forces have equal and opposite reactions. Let's take a look at these one at a time. Cool? All right, so law 1. We could say that this is the official first law of motion. An object at rest will remain at rest, and an object moving at a constant velocity will continue moving at a constant velocity unless acted upon by an unbalanced force. I know, I'll let you read that again. Okay, you got it? All right, so look, all this means is that an object that's just sitting there is going to keep sitting there until something changes it. And some object that's moving is going to keep on moving unless something else changes it, right? This makes sense, doesn't it? Okay, think about a soccer ball just sitting in the grass. It's going to stay in place unless something moves it. So then you come up and you kick it with a force. It's not going to remain at rest, right? And here's the deal. Technically, that soccer ball is going to keep on flying in that original direction with that original motion forever. Well, we know it doesn't really, so why not? Is old Izzy Newton wrong? No way. There's some unbalanced forces that's going to bring the ball back to reality. Any ideas which forces? Yeah, gravity is going to pull it back down. Plus the friction of the air is going to slow it down too. This idea is called inertia. Inertia is a tendency of objects to resist any change in motion. Let's look at that definition. So there's the first rule for how everything moves. I guess to us it sounds pretty obvious, but we got to remember that 400 years ago, this was pretty revolutionary stuff. Okay, so what's the second law? Well, the second law of motion officially says the acceleration of an object depends on the mass of an object and the force applied. What does that mean? Well, the more force you put on an object and the smaller it is, then the faster it will accelerate away. Think about kicking a bowling ball instead of a soccer ball. Not only is that a horrible idea, but also the bowling ball isn't going to accelerate even half as much if you kick it with the same force. So what Newton said was that the force given to an object is equal to the mass of the object times its acceleration. It's a pretty famous equation. Force equals mass times acceleration. Or even more simple, F equals m times a. This means you can figure out how fast something is going to accelerate if you know its mass and how much force you give it. To calculate the acceleration, you just divide the force by the mass. To use the same symbols, we write a equals F divided by m. So if you push an empty shopping cart with hardly any mass, it's going to accelerate away really fast. If you push with the same amount of force a full shopping cart with way more mass, it won't accelerate that fast at all. So the second law of motion is pretty cool because it lets you calculate the exact acceleration if you know the force and mass. All right, so 2 laws down and 1 to go. This is the one where people like to say every action has an equal and opposite reaction. Well, let's look at Newton's third law of motion like this instead. Forces act in equal and opposite pairs. This means that every time you take a step, you apply a force down on the ground, but the ground also applies a force up at your foot. Think about that. The ground is pushing back when we walk. The desk is pushing back on the good old number 2 pencil, and when we sit, we apply force to the chair. The chair is pushing right back on our Well, you get it. All right, so here's an example. Have you ever been in those bumper cars? You know, you see that there's always a kid that can't get his car to go, and well, that's the first guy you're gonna go after, right? So what happens when you crash into him? He goes flying. But did you also notice that you feel the collision too? Yeah, you crash forward and the seatbelt jerks you back. Even though he was just sitting there, that kid's bumper car applied an opposite force back at you. Forces act in equal and opposite pairs. So those are the laws of how objects in our lives move. 3 rules that explain pretty much all motion. Thanks, Isaac Newton. Keep rocking on, and until next time, it's Angela saying, may the force be with you.